Welcome back. In this, we will be talking about a little theory. So I have just put my notes to understand this. So first thing that we need to discuss is about the fundamental theorem of algebra. So when we are talking about the fundamental theorem, we are saying any polynomial of degree n has n roots. Roots implies the zeros, but we may need to use complex numbers as well, right? For example, x squared minus 9, the roots are plus minus 3. We have two roots, right? So we have discussed about the complex numbers earlier. We will discuss more about complex number in these notes as well. So we can write the polynomial function as a times all the roots, right? X minus b, x minus c, and so on. So this type of factorization is called a linear factorization, because as you can see, x minus b or x minus c, these are a linear function, right? In the form of y is equal to mx plus b. And they are easy to graph when we do linear factorization. So x minus a and x minus b, they define the roots as well, because a and b, they are the roots of the polynomial function. So keeping that thing in mind, when we talk about the complex numbers, we have discussed earlier as well, complex number, it has two components or two parts. One is the real part and the another is the imaginary part. A plus b, I. And I is nothing but a radical of -1, or I can say I squared is equal to -1. Keep one thing in mind, that complex roots always comes in pairs. That is why they have a conjugate roots. So if we have a plus bi, its conjugate will be a minus bi. Conjugate implies we are changing the sign. When we have a plus sign, it will change to minus sign. So if one root is given, it implies the another root will also be there. So we have x squared plus 4 is equal to 0. We can say x squared is equal to -4. And -4 will have I component, imaginary component. So in this particular problem, we have x cubed. So that means three roots are there: 0, 2i, and -2i, because it happens in pairs, conjugate pairs. Then we are talking about something called rational zero test. And it helps us to understand what are the possible number of rational zeros that could be there, because it is a rational means something in the numerator and the denominator. So where p and q have no common factors other than 1. So this is the basic way of writing the function down. We are starting with an and going all the way to the constant. So when we are talking about the p term is nothing but the factors of the constant. That means the last term without the x term. And q is nothing but the factor of the first term. First term means the highest power. So factor of the highest power is coefficient is q, and factor of the constant is p. If you follow these particular steps, then the things will get a little bit easier. But remember, all the coefficient, they are integers. So write the constant and find its factors. The second step is write the leading coefficient of the highest degree, x term, and find the factors. Then find all the combinations of p and q by dividing every value of p that you got, every factor of p, by every factor of q. And when you do that, you will find that there are certain numbers that are repeating, that are duplicating. So we don't want the duplicates. So remove any duplicate that you might get in step number 3. And once you have all the duplicates removed, whatever is left over, then the process comes for trial and error. And we need trial and error to determine if any factors that we got in the P and Q format, they are actual zeros of the polynomial or not. Here's the thing. When the list of the possible zero is small, then it is a good idea to just evaluate the function. For example, what does f of 3 have? And just find it out. But when the list is pretty long, it is a good idea to use the synthetic division and sketching the graph. Let's take a few examples and understand how this theory can be implied, can be understandable in the real problems. So the first problem that we will be taking is finding the rational zeros of f of x, which is 2x cubed plus 3x squared minus 8x plus 3. Now, identify what is a constant and what is the leading coefficient of the leading, what is the leading coefficient. So a0 is 3 and an is 2. So we can find the factors of 2 and factors of 3. So factors of 3, that will be the p part, right? P over q. Factors of constant is p part. Factors of q or factors of 2 will be plus minus 1 and plus minus 2. So now we have done step 1 and step 2. Step 3, possible rational zeros. So write in the form of p and q, divide every p by every q. So we can say plus minus 1, comma, plus minus 3 divided by plus minus 1, comma, plus minus 2. And you can write all the possible combinations. So let's try to write all the possible combination. And after writing all the possible combination, we can eliminate the repeated factors. So when you eliminate the repeated factors, you will be left with plus minus 1, plus minus 3, plus minus 1 half, and plus minus 3 half. At this point, now the last step is trial and error. So we will use synthetic division. And remember, for the synthetic division, we have discussed it in the last video. We will write all the coefficients and we will take one of the factor. So let's take 1 as the factor. That means x minus 1. So x minus 1 will be x is equal to 1. So k is 1. So remember, we do diagonal multiplication and vertical addition. Bring the first two up, down, and then diagonal multiplication, vertical addition. And after that, the last term is 0. And when the last term is 0, it implies that 1 is a factor. So x minus 1 is a factor, is a factor of the polynomial. I can write the leftover, that is 2, 5, and negative 3. It will be 2x squared. Why 2x squared? Because we started with the x cubed. But after synthetic division, it reduces. X cubed is not there anymore. We are left with x squared. So 2x squared plus 5x minus 3. And I can use the synthetic division again, but here's the thing, this is a quadratic, right? And I know how to factor the quadratic. So let's factor the quadratic. Two x squared plus 6x minus x minus 3, because I can factor 5x into 6x minus x. And then I will get all the factors as x minus 1 that we already got. So 2x minus 1 and x plus 3. So this is in a linear factorization. All the brackets, they are in linear format. And with this, we can write all the zeros down. So the key component is you don't have to apply the synthetic division again and again. After applying one synthetic division, you are getting a quadratic and you know how to factor the quadratic, then apply the quadratic, right? So we will get the roots as x is equal to 1 from x minus 1, x is equal to 1 half from 2x minus 1, and x is equal to negative 3 from x plus 3. Now you have seen me how I solved this question, right? Finding p and q, and then the factors, then trial and error, and then the quadratic. Try one question on your own. and practice it. So try this one. Find the rational zero of this lovely equation. And then after this, we will jump to the another concept that is called conjugate pairs. Conjugate pairs, that means we are talking about the complex numbers again. So let's get started with the conjugate pairs. So when we are talking about conjugate pairs, that means if one root is there, I can write the conjugate of it, and then it will be the second root. So we are looking for that f be a polynomial function that has real coefficients. So we are not looking for the coefficient as imaginary, right? So that is the example, right? So it doesn't have a real coefficient. Okay, so let's understand with one example. The type of questions that you will see in conjugate pairs will be, they will ask you to find the fourth root or the any other root for the given factors. So question format will be find the fourth degree. I think it is a little bit glitchy. It will come. Hang in there. There we go. So find the fourth degree polynomial function with real coefficient that has -1, -1, and 3i as zeros. So we need to write the function. We need to write the f of x, right? So 3i, it is my complex number, right? So its conjugate will also exist. So I know the fourth root will be, so 3i has a real coefficient. Coefficient is 3, right? Therefore, its conjugate, -3i, will also be a 0. So we can say there are 4 roots, -1, -1, 3i, and -3i. So -1 is the repeated roots, right? So if I have to write the function, I can say the first thing that we discussed in the video, how to write in the linear factorization, a times x minus root 1, x minus root 2, and so on. In this case, we have 4 roots, so we will write 4 times. So x minus root 3 and x minus root 4. So let's write down in this equation, root 1 is -1. So remember, we have a -1, and negative is already there. So x minus, in the parentheses, -1. So be careful with the negatives. So I am writing it down with the different colors so that you can understand that there are 4 different roots. Let's clean this up. So you will get a times x plus 1, another x plus 1, x minus 3i, and then x plus 3i. So let's open the brackets and combine the terms. And for simplicity's sake, let's take a is equal to 1. And when you combine x plus 1 and x plus 1, and then we will combine x minus 3i and x plus 3i together. So combine the first two and the last two. So you will get a lovely equation at x squared plus 2x plus 1, which is a quadratic, times x squared minus 3i squared. Now remember, I squared is negative 1. So we have to do more work in the second part. So that will be negative 9 times negative 1, because I squared is negative 1. And that will give you x squared plus 9. 2x plus 1 times x squared plus 9. And then we can do distribution again to get the function in the fourth degree polynomial, because that's what they asked for. They asked us to find the fourth degree polynomial function. So the fourth degree polynomial function after the distribution will be this. So what we did in this problem, we found the fourth root using the conjugate pair concept, and then we wrote it down in the linear factorization format, and then we try to multiply and combine the like terms by distribution. So try one problem on your own, because just by looking at the question and the answer, you will not get the feel how to solve it. So solving by your own hand will really help. So I'm giving you two functions, two different problems, A and B, with two different roots. So you have to write two fourth degree polynomial functions. Okay. After this, we will jump to one other concept, factoring a polynomial. So 3.4 is a big chapter. This is only first part. The second part will be in our separate video. So in this, we are just discussing about the zeros of the polynomial function. So the last thing that we will discuss in this is factoring a polynomial. So remember, when we are talking about factoring a polynomial function, what we are looking for, we are saying that the degree, which is n, should be greater than 0 with real coefficients. And it is in the format of a linear and a quadratic factors, again with real coefficients, right? And when we are talking about the quadratic factors, what we are looking for, where the quadratic factors have, because there might be a case where the quadratic factors will not have the real zeros. So when we are talking about no real zeros, we are looking for a prime or irreducible over the real. That means I cannot reduce it further. So that is said to be prime or irreducible over the real. I will help you understand with the example. So what are prime numbers, right? Keep that thing in mind. And it is not, we cannot do any further reduction. For example, we have x squared plus 1. X squared plus 1 can be written as x minus I times x plus I. Right? So this is the whole entire understanding of quadratic factors have no real zeros. So the type of questions you will see in this particular category, they will give you a function and they will give you a one factor. So the format will be something like this. Find all the zeros of, in the previous problem, we need to write the function. In this case, the function is given. So find all the zeros of f of x is equal to x to the power of 4 minus 3x cubed plus 6x squared plus 2x minus 60. Given that 1 plus 3i is a 0 of f. Now we know 1 0, 1 plus 3i. And we know whenever we are talking about the complex number and the zeros, it comes in pairs. So if 1 plus 3i is a factor, that also implies that 1 minus 3i will also be a factor, right? So let's write it down. Complex root, conjugate pair, and they occur in a conjugate pair. Conjugate pair, and that is why 1 minus 3i is also the root. Now, once I know there are two roots, right? We can write in the linear factorization format the factors of f of x. So we can say factors of f of x will be x minus first root, which is 1 plus 3i, and then times x minus second root, which is 1 minus 3i, which is nothing but the conjugate pair of 1 plus 3i. And then we can combine x minus 1 together, leaving 3i. We will do the same thing with the second one, x minus 1, and then leaving 3i. Let's combine these two. So we have x minus 1 twice. So we can say x minus 1 squared and minus 9i squared. Because basically this is in the format of a plus b times a minus b, which is nothing but a squared minus b squared. So a in this case is x minus 1 and b in this case is 3i. Remember, I squared is equal to negative 1. So I squared will be replaced with negative 1. That will make plus 9. And if I solve x minus 1 squared, I will get this lovely equation x squared minus 2x plus 1. But what is this x squared minus 2x plus 1? This is called a divisor. So basically, we have divided the f of x function by this divisor to get the roots, to get one of the roots or the pair of roots. So at this point, once I know the divisor, let's do long division. These problems, they are a little bit lengthy. So we will write the f of x function inside the house. And then divisor outside. And then we will start dividing. So long division will work the same as you know about the long division. The powers, they are working just like the placeholder. So we want to get rid of x4. How? Let's multiply the divisor by x squared. And then we will subtract the whole entire expression. And we will get the leftover is bring down 2x and negative 60. Now my goal is to get rid of x cubed. How will you get rid of x cubed? By multiplying by negative x. And then cancel out negative x cubed. So the leftover is negative 6x squared plus 12x. And at this point, I can bring negative 60 down. Now the goal is to get rid of negative 6x squared. And in this process, let's see if we are able to get rid of the whole entire expression. So if I multiply by negative 6, oh wow, we are able to get rid of everything. So the remainder seem to be just a 0, right? So we can further elaborate the factors of f of x. We have a divisor, which is x squared minus x plus 6, and we also got the quotient, which is x squared minus x minus 6. Remember, both the divisor and the quotient, these are the two components of the linear factorization of the f of x. So let's write everything down, the quotient and the divisor. Let's write down there, we can factor it further, the quotient can be factored further because it's a quadratic, x squared minus x minus 6. So which is nothing but x minus 3 times x plus 2. Now, for the divisor, it is already factored because that's what we started with, the two complex roots, right? X minus 1 plus 3i and x plus 1 minus 3i, right? These are already, so the divisor is already factored because we started with the factor to get to the divisor, isn't it? But when you are writing the complete factorization, this is how you will write the complete factorization. This is the complete factorization of f of x. And at this point, you can write all the zeros of the function. So zeros are 1 plus 3i, then x is also 1 minus 3i, and x is equal to 3, and x is equal to negative 2. So we were aware about one root, 1 plus 3i. From that, I got the conjugate root. So, but there are not only two roots. There will be more roots because the highest power was 4. So to get those two roots, we first calculated what could be the divisor. We did the long division, and remember, both the divisor and the quotient, they comprises the real factors. You will need a whole lot of practice with this. So I'm writing one question for you to practice. It is not very complicated, but you need to try at least 4 to 5 questions. Once you get the hang of it, then it will come a little bit easier. And this question is asking for to write in the linear factorization format. That means a times x minus root 1 times x minus root 2 and so on. And list all the zeros. So practice, practice, practice. That is the mantra for this chapter and all the mathematics. And I will see you in the next video. Bye-bye. Thank you for watching.